So we have learned what dew point is. We have learned its usefulness. Now we're going to learn how to measure dew point temperature. There are three basic models. Actually, there's four basic models. We review three of them here. One of them you can do in your kitchen. One of them you can do in the lab at CCM. And one of them is for going up in the radiosondes, and has been used also in other applications as well. The one you can do in your home is the dew point, the ice can method that's right here. And you can do that in your kitchen. We'll go over that. The one you can do in your CCM lab is the slings psychrometer method, which is a device that you spin around and you evaporate water off of it. And this one, the chilled mirror hygrometer, has been used in the radiosondes that go up with weather balloons before, but now it is used more often in industry. So let's go over their methods and how they differ. The first two use the same method. The ice can method and the chilled mirror hygrometer use a method that chills a surface. So they record the temperature of the environment, they chill a surface. With the ice can, you are chilling the aluminum or metal can that is holding water. With the chilled mirror hygrometer, you are chilling a mirror that can reflect really well, so that as you chill the surface will start to beat up with condensation. At that temperature, that is the dew point. When it starts producing dew on the surface, you can see the dew there. You record that temperature, and that is your dew point temperature. It's elegant, it's well done, it's very accurate. It's a great method to use. There is another method that you could use at CCM, and it uses a sling psychrometer. This has been around since the 1700s, and some people say that it's been around since the 1600s. This method is more complicated, but it also is not a direct measure. So in looking at this, this is two thermometers side by side on a handle. And in fact, I'm going to show that to you now and come back to this slide. So what this is a handle that you hold in your palm that has a surface that you can spin around, and the surface holds two thermometers. One is called a dry bulb thermometer, and it stays dry and records the environmental temperature at the start. And one is called a wet bulb thermometer, and it has a cotton sleeve on it that you wet. And then you spin this around and you record the temperature when you have the wet bulb as dry as you can make it. So it is recording, instead of it recording the condensation temperature, it is recording the amount of evaporation you can get off of that sleeve by spinning it around and creating a wind. So you twirl that around for an evaporative wind, and you record the temperature on the surface that was wet and now is sort of dry or maybe completely dry. You record that temperature, and then you find the difference between the dry temperature and the wet temperature, just like you would for a dew point. You would find the difference between the environmental temperature and the dew point temperature. This may still be wet. This may not be at dew point. So you need to calculate the dew point from a set of graphs that were devised in the 1700s. It's a lot of steps to do, but you should know that this method is commonly used even today by house painters, and it tells them whether or not it's a good time to paint the house and whether or not it will dry effectively. So for instance, the house painters don't necessarily do all the calculations to find the dew point. What they are looking for is a big difference between the dry bulb environmental temperature and the wet bulb evaporative temperature. If they see a big difference between those two temperatures, they know that the environment is dry, and that will dry their paint. It'll absorb the moisture from the paint, and that's what they're looking for. If they walk into a kitchen and they register that it's 80 degrees, they swing around the sling psychrometer and they can dry or nearly dry the cotton sleeve to 60 degrees, then they know it's a good day to paint. If they see a really small difference, or if they see no difference at all, then they know that the environment can't effectively evaporate the water out of the paint to dry the paint, and so they don't paint on that day, when there is a very small difference or no difference at all between the dry bulb and the wet bulb temperatures. So that gives you an idea. This isn't a direct measure, but it is an easy approximation that painters use all the time. Hope that helps you out. I'll see you when we talk about fog.